we don't find those survivors as an island, we will be left with no coral. There'll be nothing to work with, no live stuff. So we're in the White River Fish Sanctuary, 150 hectare protected area, no take fishing zone, and I'm Felix Charnley, coral scientist, working with the sanctuary, and I've been here since the summer.
So we're talking about the bleaching of the coral reef, and last time we spoke you mentioned that since September, right?
Yeah.
There have been a massive bleaching episode.
Yeah.
Can you tell us a little bit more about that?
People still talking about coral bleaching, because coral bleaching is something we've been seeing for since the 90s now, large-scale coral bleaching events. But actually, when you talk about bleaching, people think that it's something that we will recover from. But at this point, it's not really a bleaching event, it's an extinction event, because they didn't recover. There has been recovery out there, but it's a very small fraction of what really stressed over the summer. So bleaching was in the late summer, but it only took 3 weeks for it to become a mass mortality event as opposed to a bleaching event. So yes, we had almost 100% bleaching of Jamaica's reefs, island-wide, and that really kicked in, I would say, on the 1st of September. We saw everything just completely white. But for the species that we target in restoration, which are the elkhorns and the staghorns, you know, the golden species, the branching corals that really constitute the foundational structure of Caribbean reefs, those all paled immediately, but it only took about 3 weeks for them to just die. So at that point it was a near island-wide extirpation of that genus, that critical genus, which is the foundational structure of our reefs.
Explain bleaching.
Bleaching is when the corals stress, they lose their pigment because the microalgae that inhabit the skeleton that gives it its color is expelled, because and that's its food source. It provides its nutrients in addition to its color, and so it's just a stress response. When it stays white, those microalgae within the water column can re-enter and recolonize the skeleton, but it'll only recover if temperatures go back down, or if the stress factor is eliminated. So that didn't happen, and it's only a matter of time. You know, we don't know for sure what that length of time is that each individual species or even genet can withstand and stay bleached without recovering or dying, but we saw this year that it was about 3 weeks for the corals that we are focused on. So yes, bleaching is a stress response. It's a temporary state from which corals can either recover or not. And the bleaching events are becoming more and more consecutive with the years, and they're also an opportunity for us to find corals that don't bleach. It makes it easy in a way for us to identify what's strong out there, and flag those, which has been basically our approach from here on in. From the summer onwards, we've been flagging the survivors, and we're going to be prioritizing those in restoration, and we've got a roadmap for doing so, and that's why we spearheaded alongside other in-country colleagues the Resilient Coral Mapping Network, whose mission it is to find those survivors, multiply them in situ and bring them together, and then we can get into the sexual assisted fertilization game, which is to really crossbreed them in a controlled environment so that we can breed stronger genets to start fresh new populations of climate adapted corals. Temperatures hit around 33 degrees, that was an average here in September and October. That's what killed everything. But yes, those survivors, and they're very few and far between, survived 33 degrees, but no one's saying that they're going to survive 40 degrees in the next maybe 5 years. It's what we have to work with, and that's studying their performance in the coming years is what's going to be particularly interesting, and that's going to be our approach. It's what's going to inform everything we do, and that is all that's left, so we have no choice.
And when we talk about Jamaica's Reef, what areas are we talking about?
The entire coastal shelf has been affected by this. We're not speaking about any one particular area. And here's the thing, we would have originally only worked within our loosely defined geographical scope here at White River, so within the sanctuary, within the wider Ocherius Marine Park protected area, which is, Mame Bay to Frankfurt Point, and then, after that you get the other sanctuaries, so like Orcabessa, Boscobel. So but none of that matters because, you know, the global temperatures don't care about these parish boundaries or anything like that. So we have had to take it upon ourselves to map these survivors as far as Greenwood in St. James and in that direction, and then heading east we've got as far as Tower Isle, so going into St. Mary, and that's where we're headed next. You know, we need to expand there, team up with the other guys, all the other sanctuaries. When we started the network, it was a WhatsApp group. There's 30 plus individuals in there. It started off with a representative from every fish sanctuary, coral restoration nursery program in the country, pre-existing ones, and also spearfishers and just useful contacts, people who have helped with the logistics in every parish. Say, you know, accessing the coastline in Jamaica is controversial, so you need to work with people who can actually help provide that access so we can get in the water and do what we need to do. So there are people who can help with that in the network, so that's also been fantastic, and we just have to go far and wide to do this.
How many hours a day would you say that you're out and trying to restore the coral?
I can spend up to 8 hours a day in the water mapping, but that's just because I'm me. You know, it takes a certain type of personality to really be that obsessed. But I get carried away, and that's it. You know, it's just about sticking your head in every single nook and cranny to find a survivor. And survivors, for the most part, are small. We've lost those huge assemblages of elk-horn corals that basically built those entire spur and groove systems. So, generally speaking, no surviving corals are wider in diameter than, say, 1 meter across. We found one or two over in that direction as well, which is really exciting because that's quite close to base. But for the most part, I'm finding stuff this big, and you know, that gives us very little to work with to multiply, propagate, and ultimately get into assisted breeding.
What would be a typical size of coral?
So typically a survivor can be, say, like the diameter of my forearm. You know, that's an adult colony, but I mean, I've been finding, you know, juvenile spat that's for some reason survived. With this mapping, what I've been trying to establish is a pattern to survivorship, and I've had to kind of accept that there isn't one, and we just simply have to go deep, we have to go shallow, we have to stick our head in every single little crevice, because it would be great if we could help prioritize sites. So, okay, we're going to stick in the deep section because that's where there's more probability of finding something, or we'll stay in the shallows, but it doesn't work like that. There could be anything anywhere, you just have to cover every bit of ground. In fact, it's almost where there's more, where there was more, I seem to be finding less, because you go to these huge assemblages where it was just nothing but elk-horns and staghorns, just stacks of it. But I think it's very telling of that genus's primary reproduction tendency is asexual, meaning that, you know, it's all genetically indiverse. So if one gets it, the whole thing gets it. That's why where you see mortality, it's widespread in one area. But it doesn't really explain why, if I go to a place where there's very little around there anyway, but I find one thing and it happens to be alive. It just, it's strictly down to genetics. And we know this because people say, okay, well, maybe we found some survivors because of the environmental conditions being preferable at that site, but it's not, because every little survivor is surrounded by 100 dead ones. So it's all genetics from here on in. It gets complicated because it's not just whether or not a coral bleached that really tells us how it's going to perform in the future. It could be the metabolism, you know, things that you want to be studying in laboratories that, you know, it gets technical. But basically, we're going to be studying the performance of those corals from here on in to really inform where we go with this. When the bleaching kicked in the first week of September, we carried out an experiment, so this was early on, to shade the nurseries. This is something that I've had success with in the past in other countries. But 2023 was just too much. I mean, it was an atypical El Nino event. Yes, it's global temperatures and anthropogenic climate change, global warming, but that coupled this year with an El Nino, the heat in combination with the luminosity, the light intensity, that UV penetration from the sun can also cause things to bleach. So in previous years, it's been beneficial to actually shade corals, but you want to do so ahead of time. I feel we kind of acted late because things are already bleached, and we tried to get things under there. So we didn't visibly see a difference. But having said that, you know, in the first week of December, I went and checked the nursery that had been shaded, and one or two things pulled through or had started to recover. So everything bleached, but some things were actually regaining color. I don't know why those ones were actually regaining and the others weren't, but I think it could be down to having done that experiment in the first place that we do still have some of that original nursery reared material. But otherwise, everything that we work with from now on has been found in the wild, and that's because it just was never going to bleach in 2023.
And that shading component, what's the materials that are used for that?
Oh, we just used a shade cloth, a typical, like you would with a plant nursery, and we just anchored that down. We built a little frame where we had the corals, and we were able to stabilize that. On top of them, we had two tables. One of the tables was already down there from the time that Rianne McKenzie was managing the nurseries here, and we just managed to work with that system and shade it, essentially. Our approach from now on is basically all down to genetics, and with this mapping thing, we do these 5-kilometer swims or more. I can be in the water for 8 hours a day or more, and I'm trying all the while to establish a pattern to survival, and I'm just having to accept that there isn't one. You know, you could find survivorship in the depths, in the shallows. In fact, because the main reproduction mechanism for these types of corals is predominantly asexual. They do spawn, and they do sexually reproduce but once a year, and the success rate of that is incredibly low because of all the other challenges out there with algae and everything. It's predominantly asexual, but that's why if one thing gets it in a whole assemblage, everything gets it because they're genetically singular.
Understood.
So your question though, how do we know that something that survived the 33 heat in the 2023 scenario is going to survive 40-degree warming in the next 5 years? We do not, but this is our only hope.
But we know that 28 is a thing of the past.
It's threshold, yes.
So you start at 33 and see what happens?
You start at 33, see what happens. We do these experiments, studying these survivors. If we don't salvage these survivors now, we'll have nothing to study. But if we salvage them now, we'll be able to study what survival patterns and how those will behave in the coming years, but also we need to get into the crossbreeding game. So we need to start spawning things in labs, and that's phase 2. So when we get the money, we need to get into phase 2. So phase 1 is salvage and share between protected areas and multiply.
Regionally, who's had the best success? I know Bahamas had a crisis 5 years ago.
Regionally, you've got these groups like
Coral Vita.
yeah, but you've got they're doing farming of again asexually. Belize has had the most success region.
Okay.
Why? Because their approach is ours, but 15 years ago. They were informed by a population geneticist called Ileana Barnes, who told this lady Lisa, who works from Belize, to get genetic samples of everyone out there and start breeding the most genetically diverse population as possible. And to this day, they had what we had, but they've got survivorship because they really mixed and matched. So we didn't do that. So now we're playing a catch-up game, and we need to go and find that variance. That's right. So we need to share everything, but multiply asexually. And we have this silvicultural method that Andrew Ross has been developing in Jamaica, and that's pioneering stuff. To really maximize the number of individual colonies we have and do it in a way that's, you know, secure, swell resistant. We've been developing new designs for doing that. And then phase 2. So expand that search island-wide. So this is what we're talking about with Rachel, going out to Pedro Banks and everything, and we really want to go that far because we have to. But then from there, we need to get into spawn.
And protection declarations don't mean anything if you don't make interventions to actually make protection worthwhile. So
I'm just going to put a couple of that. And then step 2 of phase 2 would be to start getting the training, acquiring the knowledge. So whether we go to the Dominican Republic or we go to Florida or Mexico or Honduras, where they are successfully doing assisted fertilization, we get that knowledge. We would also like to get to Cayman, where they're doing the first stimulated broadcast spawning, because yes, corals spawn at the full moon in August or September once a year, but if you can, they're working on actually stimulating that process to occur at the time of year outside of the typical season, so that we can, breed faster. So that's
what's your lab capacity here?
Iberia Star Wave Change Foundation, Discovery Bay.
So Erica Harms, that's how we can do it.
That's right. And Joanna and Macarena, who are part of the foundation, who come and do pop-up labs. They do thermal tolerance testing.
Ask Erica.
Erica, yeah.
In
Yeah.
Pristine Seas. See if you can get a feature in National Geographic. That will also help you.
Pristine Seas.
That will help you with your search for international funding. Yeah. So that attention about it. She knows Enric very well. Enric is he's an explorer and waiting for National Geographic and heads Pristine Seas.
Sorry,
Enric Sala.
Okay.
He did a preliminary strategy for the protection.
Okay.
In terms of the areas that need to be protected.
So yeah, that's the lab capacity. Discovery Bay, when they've got the space, we would love to be working out of Discovery Bay. Again, logistically, it makes so much sense. Alligator Head also has a system, but it's just a matter of really overcoming the learning curve of working with these types of species that are particularly demanding when it comes to nutrient consumption and everything. So it's a big learning curve, and we need to get abroad, get the knowledge, or get somebody in, SEEK or International, Fundamac, whoever it is. So yeah, phase 2, if we can get that happening in 2024, more like 2025, could be fantastic. But we won't have anything if we don't start the mapping, or continue the mapping. So basically, what's it going to cost us to do that? We've outlined the logistical costs of phase 1 to be around 50,000 US, because we're talking about boats to go further. We've got to go back to these colonies to really check that they're okay. But we've got to, it's quite an undertaking to bring them either back here or just spread it out. And then phase 2, the travel and everything, the training abroad, we're looking at upwards of 500,000. If, of course, depending on how many island-wide practitioners are going to get into the spawning game. So that's just that little breakdown. And so far, we've got this relationship with CAF, who, as you know, were at COP, and they have said, well, they give upwards of 14,000 million or have to Latin America for coral restoration in the past. They've offered to get us to, jump in on the Colombia workshop on spawning, which is happening this spring. If we can get the government endorsement for this mapping network to basically be nominated as a country team in response to this crisis.
So, Zuki, write to Simone Lloyd at the office, running the spatial management unit. You need to get her out here as well. They have the government. They basically do all the mapping for them. So they would have some capacity that I've instructed them to lend or give access to in terms of mapping space. They do all of the I forget the name of the software. But whether it's they have all of the GIS software. There's another type, but and all of our satellite access is through them. So whether it is where there's a car accident or where there's a building or where there's an environmental issue, they're the ones that do all the mapping. So I think them understanding and starting to bring that information into
So Simone, sorry.
life. We'll reach out to you from that.
Yeah, great.
Connect you. I'm gonna ask them to come out here or something.
And that's government.
So then all of the information, all the GPS,
Yeah,
all the
it
stuff that we're
has to be
trying
concentrated.
put into a national grid. So
Yeah.
that
And that's not NEPA, that's...
Well, it's the Ministry of Economic Growth and Job Creation.
Okay.
NEPA is assigned to,
Yes.
so I mean, I think it's going to require some ministerial oversight to bring everybody together to get them functional. Because if the priority of spatial management may not be your priority at the moment in terms of things they're working on, but if we don't bring a task force together to be able to respond to people on the ground, then we have some challenges.
You were made aware of some issues facing our coral reef today. Based on those issues that were brought to you, what can you say in terms of what you're observing and what can be done?
So, population would recall the drought of last year, and persons remember just how chronic that really was. But what the population, I'm not sure, has quite grasped is that in July and August of last year, Jamaica broke temperature records. I believe in September it tied temperature records as well. Now, that would have prompted surface water to increase in temperature and would have started a coral bleaching event sometime in around September. It's something that we've been tracking very closely through NEPA, Marine Authority of Jamaica, and indeed through the Fisheries Authority. So it is something that we've been tracking very closely from as far back, I believe, early September. Most of our marine sanctuaries are managed by NGOs with the support and legal support from the government, so to do. They've designed a series of interventions. So certainly the team here at White River, the teams at Alligator Head Foundation, the teams at the Discovery Bay Labs, all have designed their own interventions because in many ways the species and the genetic makeup of your coral is different. So you have to allow each team to do their work. I wouldn't say that it's something that the response can be quick and managed when you have a mass bleaching event like that in the way that you'd want. It's not a light switch. We're going to have to do significant work on the resilience of our coral species that we have in Jamaican waters, understanding that there will be continued warming, not because of anything Jamaica has done, but because of global warming brought about by climate change.
Mm-hmm. So is there any monetary intervention that the government can assist at this time?
The government is committed to preserving the coral population, and the government will have to make a financial contribution. We'll have to engage other international partners as well. I can't give you a figure right now because I work very closely with Minister Bartlett and Ministers Green, as we're all stakeholders in the preservation of our coral reefs. We don't have a lot of time, and admittedly, whereas we're not the only Caribbean nation that faces this, we're going to have to move faster to play catch up with the environmental changes that we are facing.
Going forward, what are some of the key things that needs to be implemented to ensure that we can recover?
If we don't find and flag the survivors, then we have nothing to work with. So that's number one. We have to find them, and we have to somehow increase their biomass. So we have to exponentially multiply them. We have to clone them so that there's enough to share and do these experiments with that will take us, take Jamaica forward in the restoration game. Because Jamaica's been pioneering asexual propagation for since the early 2000s. With Andrew Ross and Seascape Caribbean and Yui having done even invented some of the standard propagation systems, the coral nurseries, those designs. But Jamaica has yet to get into the whole assisted fertilization program. And what we really want to do is, if we can, there is new science being developed to stimulate broadcast spawning, because corals spawn, they reproduce sexually once a year, in the full moon, August, September, and the success rate of that is very thin because for coral spat to really recruit and grow, it has to have an ideal habitat out there. But everything is so heavily dominated by algae, and we've got such overfished reefs. It's very hard to really depend on that. So that's where, I hate to say it, humans come in, and they can be more beneficial in that sense, and we can actually do it in a controlled environment and get them to recruit in a laboratory system in a tank, and then we can bring things back out to a strategically selected site. It could even just be the nursery itself, in water nursery. But another thing, in order to not depend on this phenomenon occurring only once a year, is to work with these new researchers who are trying to find ways to stimulate when it can occur so that we can make it happen more frequently.
The intervention in terms of protecting your environment is never free, and it is backed by significant investment being made right along the coast in our sewage systems. It's not just the warming environment that is causing an issue. As you have population growth in town centres along your coastline, you get particular environmental pressures. One of the largest ones being sewage. When you have increased nutrient flow, you have increased algae cover on your coral, which makes it less resilient or less able to deal with the heat that we have. So it's why, and if you follow anything that I'm doing with water, you would see that we're making significant investments in sewage, and it is a matter of urgency, because ultimately we're also going to have to reduce the nutrient flow. It means we're going to have serious conversations with all of our citizens who live along rivers also, because that's ultimately how the nutrient flow happens with into our nearshore environment, which is where primarily coral cover is. So there are a number of elements that come together to create a particular issue that we face. It's just that we will be making the interventions that ensure that the issue that it faces doesn't become a crisis, or a permanent crisis rather.
So it's something that we can look out for within this year?
Certainly. It has to happen this year because the reality is with the El Nino phenomenon there, you have another 2 to 3 years of intense heat. So the intervention is time sensitive. And I'm happy for the work of the NGOs who I think have been on the front lines. We do interact with them through NEPA and through TPDCO and through the Marine Authority, and there is a coordination effort underway. I think the intention will be now to ensure that it gets a bit of a push to move further and faster.
If we don't find those survivors as an island, we will be left with no coral. There will be nothing to work with, no live stuff. It's important to understand that this near extinction event, 2023, has told us that we're not really doing ecosystem restoration. We're not restoring patches of degraded reef at scale. We are literally doing endangered species salvage, rescue, conservation, to keep those species alive that we can, if conditions improve, utilize to regenerate patches of reef. But none of that's going to happen if we don't leave fossil fuels in the ground and if we don't halve humanity's footprint. You know, you can't oversimplify something as wicked as that, but we need circular economies, and we need to just stop the machine. So big ups to all the people out there blocking roads, because that's the action that we need.
What are the dangers to the island if the corals are not restored? And is there anywhere else in the Caribbean where they're having the same problem?
This bleaching event / mortality event was regional for the Caribbean, and that heat now is heading towards the Pacific, so it's been global this year. The last 12 months or the last 6 months so far have been devastating globally. So, you know, it wasn't just Jamaica. So far the region has seen the same mortality. But it's been difficult to get fresh data because it's A, very recent, and B, a lot of people just haven't yet reported what they've seen or haven't been in the water. And I would say that, you know, we've been in the water more than a lot of people, because I can safely say we've seen over 90% mortality of the corals that we are looking out for. But I've been speaking to people Florida got hit with severe bleaching in July, and we were all seeing the pictures, but I haven't heard anything since. No one said whether it was 90% die-off ultimately or if everything recovered, which I'm sure it didn't, but I can eyeball it and tell you that we've lost 90% of the remaining 10% that had declined over the previous 4 decades. Somebody I spoke to in the Dominican Republic said that he'd seen maybe like a 50% recovery or survivorship of elk-horn corals. So it's been difficult to really get figures, but the implications of this event for islands and for Jamaica is enormous, because those corals are what buffer the coastline. So, you know, when that breaks down, if those ecosystems aren't self-regenerating, they will erode. So we will end up again with erosion, and we'll lose our coastal infrastructure, and that'll affect livelihoods. It'll also affect the hotels, the people who do business on the coastline, and fish. You know, overfishing has always been a problem in Jamaica, but if the fish don't have habitat, then that's just going to be, you know, much worse. So recreational as well, you know, scuba, snorkeling. What do we offer to our tourists? Are they going to really come and see a defunct ecosystem? So it's an opportunity to work with groups like us, so that we can establish nursery programs to try and build back bit by bit, and, you know, maybe that's something to share with our visitors. But otherwise, yes, the tourism is one of the number one industries affected. With this mapping mission, if we can take it island-wide, we will. So far, we've mapped the entire coastline of Trelawney, and we've basically finished St. Anne. We just need to finish a little section at Priory. to find these survivors, and we've already started with St. Mary, but we need to keep it going. Jamaica's a big place. It's the third biggest island in the Caribbean. That's a lot of coastal shelf to really cover, so that's why it's required all this community effort. But it's little, but underwater no se ve talaga.